Today I'm going to talk about microclimatic design in teaching. So as Anopiria talk about my teaching experience that I've taught at OU for 3 years, and I'm moving to the University of Wisconsin-Madison from this fall. So this spring, I get the chance to develop a new course, and then I think it's called Design with Microclimate, and then it is a kind of university level class. So we have like students from multiple majors to select the class. So there's something that I really want to share with our people today about my teaching schedule, some kind of teaching outcomes, and also some thoughts like challenges or like future opportunities that we may think about in microclimatic design for teaching. So yeah, I really want to, I talked with Bob about for today's seminar, I really want to make it, maybe leave more time for like open discussion. I want to hear feedbacks from our, students and our faculties, and especially our senior faculties and, researchers and educators, how we can spread the microclimatic knowledge to like a bigger group of students. So, okay. Oh, sorry, I should do this. Okay. All right. So I started for teaching this class, Design with Microclimate. So this is a kind of higher level undergraduate class, and then graduate students can select it as well. So we have a combination for undergraduate students from 3rd to 4th year, and then also graduate students. So this class that I teach, that I've taught in the spring, it is a 3 credits lecture, and then I made it as a lecture and a lab session, and it's twice a week. So we meet every Tuesday and every Thursday. So we have like junior and undergraduate students, or like, and some graduate students, and we have 20 students together. So in terms of the major, we have students from architecture, landscape architecture, environmental design, urban planning, and meteorology. So for the course, the major kind of goal for this course is we're gonna ask the students to understand like design with thermally comfortable urban microclimates. And then we're gonna introduce methods of analyzing and illustrating climate data, human thermal comfort modeling, and how do we apply those design strategies in landscape architecture, urban design, urban planning aspects. So for example, we ask the students to do some, like when we first like ask the students to do like a chart to demonstrate those data. Wow, you cannot imagine how many different types of the chart that students show us, pie chart or column chart, and then they learn how to appropriately present the data. And also we teach them some kind of, we ask them, we provide devices for students to use. And also we're gonna provide with some kind of design strategies. I'm gonna go with some details later. So the objectives, as we mentioned, like 4 major objectives. So first one is how to acquire, to get data. And the second is to learn those components that we can modify. And then third one will be human energy model. And the last one will be design strategy. So for the teaching method, we have like lecture and reading assignment for students. And then also we have lab projects and exercises. And then we have like a set trips and then field observation and field measurements. So it is a kind of just for 1 semester, and we have like more than 10 lectures here, and then I invited 3 guests to provide 3 more guest lecture. So this happens on Tuesday. And on Thursday, what we did was we start to ask the students to work on their exercise or project. And then they are going to work on 3 major exercises. So first one is like urban microclimate, my experience. It's gonna, so students gonna think about, start to think about the, the microclimate in urban area. And the second one is they're gonna start to do some data collection and analysis. So this is I would say the biggest project or exercise. And then the final one will be like how do they design with microclimate they're going to have a case study first, and then they're going to do a site design. So for the lecture, so first I'm going to just talk about like how what is this course about, and then talk about my research, and then we're going to start to talk about the scale of urban climate study, and then we're going to spend 4 or 5 more weeks talking about microclimatic components, and then we're going to use like 2 lectures about the CONFA model, and then we're going to use 2 more lectures talking about the design strategies, and then 3 more guest lectures. So for the textbook, I use 4 major textbooks, including 2 from Bob, and then 2 other books. So those 2, so this is the thickest one, Urban Climates by Oki. This is crazy. It's like, I will not ask the students to read about it. And then, but for this one, urban microclimatic design with space between buildings, this one, and also microclimatic landscape design, those 2 are pretty kind of, design oriented books. And then the urban climates is more like meteorology or, that area. I scanned those, some of the, chapters for students to read as a kind of supply material. And then for this book, I asked them to read as a, required textbook. And then they say they can just finish within a couple of days, and then they love it a lot. They feel like, oh, I think I'm reading a short novel. It's just, I can't stop reading. It's just so easy to read. I was like, yeah, I love it too. So, all right, so talking about the students' exercise, I have something to demonstrate. For example, the first one, first exercise, we ask the students to do like urban microclimate, my experience. So this is at the beginning of the semester, and we ask the students like based on your experience, based on your memory, or it can be somewhere during your travel. It can be, daily routine, like every day you went somewhere and you feel comfortable or uncomfortable. So they're gonna tell us the location and the climate and the space environment. So I ask them to describe what's there, what's for the painting environment, what are the design characteristics, and then do they have a fountain, do they have a tree, how big it is, and then also they're going to tell us like what's the activity, like what's the user's activity, what do people do there. All right, so for example, those 2 are different assignments from my students. The left one is just campus area in the University of Oklahoma, and she said she just passes it every day. And then she described this environment and have some kind of thermal feeling described. And then this one is from another student, and then this is from his travel to Japan. And then he mentioned this is happened in summer, and it's super hot and super humid. And then those are all the visitor, like travelers, and they are under the umbrella to prevent from too much solar radiation. And then he felt very, very hot that day. So through this exercise, we ask the students to think about the relationship between environment and microclimate and your feeling. So, and then we move to ask them, gave them some basic knowledge about microclimate. For example, air temperature, relative humidity, solar radiation, terrestrial radiation, and wind. So we're going to talk about each of the component like every week or like 2 weeks. So it depends on the content. So and then for Thursday lab day or like work day, I'm going to introduce students how to use some devices, like simple devices like a Kestrel or like thermal camera, so they can use it for their data collection. So for the second exercise, I ask students to work in group, and then they're going to work in a group of 4. So it turns out to be a wise strategy to, instead of giving them like to work them, ask them to work individually. So for a group of 4, so let me think about their job task. It's like like two students, they're doing data collection, and one student, they are doing like a GPS, they're recording their moving, and then one student is making some notes or like record the numbers. So for example, this is for one group, and then they select 4 major sites for their exercise, and then they walk through this campus, and then they hold the Kestrel to record air temperature, wind, and humidity. And then also they use this thermal camera to record, to measure the terrestrial radiation data. So for example, we ask students to produce or draw this graphic for relative humidity or like a wind. And then also we ask them to write a report for their data collection. And then they're going to tell us their data collection time, location, duration, maximum, minimum, and average. They're going to do those kind of basic analysis. And then for terrestrial radiation, I feel like this is really a kind of interesting part. And then also students are really kind of pretty excited to see those, images like thermal image or how hot it is, because they can feel it, but they don't know how the exact number, like how hot or how cold it could be. So for the terrestrial radiation, we ask the students to use like 2 types of the devices. They can pick just one of them. So one is a probe, and then students can just use it to touch the surface of the material, and then they're going to read from this device, and then or they can use a thermal camera to take a picture for that. So I ask the students to just go outside and work in group, and then start to measure different materials, and also under different conditions. For example, first I ask them to measure at least 5 or 4 different materials like concrete and wood, and then grass, or all those, or asphalt, or or other glass, or other materials that are frequently used in landscape architecture design. And also the second one, I ask them to pick 2 material, and then they're going to bring a bottle of water, and then they're going to pour the water to the material, to the surface of the material, if allowed. Like, for example, I'm going to ask them to measure the dry grass, and then they're going to pour the water to the grass and wait for a few seconds until it infiltrate to the ground, and they're going to measure the surface temperature of the wet grass one more time. And also for the concrete or for like soil, they're going to do a dry and a wet one. And also for terrestrial radiation, because we have, I think, more than 1/3 of the class are from architecture, so students. So I asked them to also select a building, and then to measure the 4 facade to 4 sides of the building, like how hot it can be, and then describe the material of the wall. So they're going to measure this in the afternoon, and then to demonstrate the hottest situation. For solar radiation, because we're going to use a pyranometer to measure it, and then that will need some kind of programming, and then using the data logger to transfer in data. So instead of asking students to do this by themselves, I use the what is called Atmos 41, the kind of compact weather station, to collect the data. And then we just ask the students to come together, and I gave them a table to record those numbers. So in order to see the differences for solar radiation in microclimate, then we went to different types of the trees that has been frequently used in the campus, and also we did some kind of building shade, under building shade, or bus stop shelter. So we went to different places in the campus, and then to measure the solar radiation in the shade, on the different types of the trees or buildings, and also we measure the open solar radiation data. And then we introduced transmissivity, like total solar radiation transmissivity, and we ask the students to calculate that. It is very simple to do, but there's a lot to understand. So all right, and then we comes to the last part, the final exercise or the last exercise. It's gonna be designed with microclimate. So first, we gave them lectures about learning from great design and also from like ancestors and also like a different part of the world. We introduced like a Chinese feng shui, we introduced Japanese landscape, and also we introduced like a Mexican, what they called, I forget the name. It's a fancy design, but we try to include like multiple, different parts of the world, and also different times of the different arrows to see what kind of design they may learn. So, and then students gonna pick their own design projects to say, okay, so what are the design feature that can actually modify microclimate? So for example, this student, he picked a building. So he said it's called an edge. Right. The building is called edge, and how it kind of save the energy for the building by taking advantage of using the solar energy. And also this student, she showed a kind of public park under a highway. So how people take the advantage of existing shadow area here to create a kind of a comfortable area. And then we ask them to pick a site. It can be in the campus or it can be somewhere else, but you want to take some photos, and then you're able to access it and also mirror the data for this site. So students, this is a kind of individual individual study, and then they're gonna pick their own site. So for the device, the group they're gonna share with each other. So for example, she picked a site within the campus, and then this is a kind of sunken garden in the kind of oval area in the University of Oklahoma. And then she started to measure some kind of basic component, air temperature, relative humidity, and also terrestrial radiation. He used a thermal gun or like thermal camera to test different materials. And then she used a comfort thermal comfort model to do some calculation for like the energy budget. And then she started to state some kind of site issues and then some site solutions. So this is from I would say a second year or environmental designs or third year's environmental design student. And then I don't think they have a pretty, they didn't do like much design yet. So I think she just write down the paragraph. And then let me show another example here. So this is from students from the architecture. And then let me see here. So first, he demonstrated the kind of a case study that he selected. It's Pally Park in New York City. And then he kind of explain why this is a kind of thermally comfortable environment, what kind of, design strategies are there. For example, building block the wind or trees, and then some evaporative cooling surface here. And then he showed this, plan and then perspective, also sections to show more details. And then he selected an area for his own design. It is a parking lot. And then he went outside to measure this, how hot it could be, the surface temperature, and also wind speed, air temperature, solar radiation, relative humidity. And then he started to use the Canva model to calculate with the energy budget. And then he's a graduate student from architecture. For a graduate student, we asked them to do this part, microclimatic modification. So we asked them to to try to play with those, like, for example, if you add a tree there, let me see. So those are no trees. And then he's kind of changing the wind, like the minimum wind speed or the maximum wind speed, what's the differences. And then he start to see if I add a Norway maple, what's the differences. And then he's starting to do like modify different parameters there. And then this is his kind of strategy. All right, let me go back right here. Okay, so yeah, this is for this class. This is a 1 semester class and 3 credits. And then I have some kind of thoughts, and then also something I really want to hear your thoughts. So first, I feel like the fundamental knowledge for microclimate study, it takes a long time for students to observe and to digest and to learn. So for example, I feel like it's already, I kind of push them every week to move forward. And then I gave them like every week like new tasks to do, and then still feel like I repeat those key informations or knowledge like several times, but I feel like students sometimes still ask me, what's that? Or, they were like, oh, did we learn about that? So from this week 3, let me see if I can move this to somewhere else. From week 3 to week 12, we're all kind of introducing those, fundamental knowledge, like how to do data collection, and then air temperature, relative humidity, wind, and all those kind of components. And also we have to teach them like how to use those devices, and then how do you transfer data, how do you analyze data, those kind of things that takes almost a third almost 3/4 of the semester, so that is a long time. So however, for the design strategy, which we really want to maybe emphasize more, it has to to be like squished in only 4 or 3 weeks in the end. And then in terms of the lecture and the lab session, I feel like this is a pretty good distribution for this types of the class. So for example, on Tuesday, I gave them lecture to introduce, those knowledge. And on Thursday, we start to work on devices. We start to go out and collect the data together. And then we start to come back to class and then to show the data and then to discuss that. So in terms of like, because I have the so they asked me like, do you want to be the 3 hours per week, or like a 1.5 and the other 1.5, like 2 days? I was like, let's do it 2 days. I feel like this works pretty well. So device issues. So those devices, we borrow those to students and then ask them to use in their semester. Like things you can imagine, like they forget to charge the devices, they forget to bring the batteries, they bring the different data, like transferring wires, all those kind of things. So as a lecturer, every time I have to bring extra batteries, I have to bring extra wires, and I have to be backup plan for them, right? So it's kind of hard to train them to have this habit working as a for the lab, for data collection. But also it is pretty good to work in group, because students can just remind each other, hey, did you charge it? Do we need to bring this? Instead of making them to work individually. And then another thing that I feel like it's a little bit weak for this class that I've taught in spring is the kind of design solutions or design strategies. So I feel like when moving from site analysis to site design, I think it's not only for microclimate, but also for some for the studio part, it's a kind of some gap there that we need to think about. How do we fill? Like for example, students can show a pretty good analysis, but in terms of the design, they're asking me like, hey, Wenwen, besides planting trees, what else can we do, right? So let me show you an example. So this is a class, a studio that I'm teaching this semester. So this is a kind of combination a class from you can see students name. We have BLA students, we have URPL, like master urban planning master students. So we have like 4 students in a group, and 2 from LA, 2 from urban planning. So they start to do, so this is a studio, and then we ask them to do like a community design. And then this is their site. And then this group, they start to work on site analysis, and they really want to focus on kind of environmental justice. So they did like land temperature, land surface temperature analysis, like impervious surface, and then also, you know, flooding issues and circulations, those kind of thing. And then they start to highlight some kind of high points. And then this is their kind of, you know, we can call it kind of, you know, kind of synthesized analysis for showing the issue area that they really need to focus on. And then they start to ask me. So this is what they showed me like last week. They said, okay, we're going to do some connections, we're going to plant trees, and then we're going to do like a green roof, right? But how do we know we're doing the right thing? And then how much energy or something that we can demonstrate this is a successful design, right? So I asked them like, because Bob talked about this multiple times. He said like the very tricky or like the smart thing is to make your design have like less efforts but have more impacts, right? So we know trees to plant, but what types of the tree, how many trees do you need, right? We want to be very strategic and then to do our design, right? So I gave this thoughts, I share this thoughts to my students, and then this is what they showed me this morning. They found this called the Green Value Stormwater Management Calculator from online, and then they start to show me, okay, only 1/4 of the roof area needs to contain the green roof, and then that will capture like 100% of the runoff with this rain event. So they feel like pretty confident in doing this, and they're asking me like, in terms of, you know, energy saving or like microclimate, do we have something to use, right? So I'm thinking of, is there any tool that we can use in class to teach, you know, microclimatic design? So so I don't know this stormwater management calculator, but I did use another one. It's called the National Stormwater Management Calculator, something like that, by EPA. They developed that, and then once you type in like, you know, your land use or your slope and your land type, and then so for example, how many acres of green roof you have there, how many acres of, you know, the forest that you have, and also you're going to tell the location, and then, you know, and then it's going to help you to calculate something. So can we work together to develop something like that for, you know, facilitate this like, you know, evidence-based design? So thoughts to share. So for the kind of, you know, lecture organization, I feel like for one semester lecture, it's very hard for us to have everything there to cover within one semester. As I mentioned, like the background or the knowledge we need to have, I would say I'm gonna spend like 3 months or at least 2 months for that, to introduce that to students, because without those knowledge, you're not able to actually learn the design strategies, right? So that is kind of essential part, but it takes a long time. So ideally, if we can have like 2 semesters, maybe we can do like 1 semester for the lecture, and then, you know, experiment, and the other focus more on the design studio. And then for this device management, I really want to learn from you guys. What kind of, you know, wise strategies I can use for students to ask them to. We're still missing one probe from one student. I call them like, and I talk to the department, to talk to the college. We have a student advisor. We just cannot get it back. So in terms of that, what can we, you know, avoid those kind of situation to happen? And also the second thing about device management is about their, you know, their I would say the lab behavior, or like how do we kind of train them? And I know this is hard, but how do we train our students to have a habit to let's say to charge their device, to collect the data after their field trip, and then to, you know, to clean the data. So they should have this kind of sequence. But Yeah, and then the third one is the gap between site analysis and research to, design strategy. I think it's not only happened to this topic, but also other topics as well. So I feel like, and also based on my observation, the Canva model, which is a very good one, and then students see the differences for adding a tree or change the clothes or like doing different activities, but how can we make it more like first like user friendly, and then also how do we specialize it? Like for example, if we have a site and then we tell like where it is, and then after we have more like a land use or land cover conditions, like, or specialize it information, how can we improve that for to use in our studio? So yeah, I guess that's for today's talking. And then yeah, I really want to hear your feedbacks, and then other thoughts. Thank you so much.